Because I think the correct answer to that, okay, so the question is, why isn't the presence of hypothetical bytes symmetric? That is, why don't we have hypothetical bytes going in both directions? And I'm looking at Li Yao to see if he agrees. The way I would explain that is that we need hypothetical bytes coming back because the server, we are the tester, and we're seeing what we're observing on our network port. So if the server is doing stuff, we may not have seen it yet. But we are running on the same machine that's generating the bytes to the server. So we can know what those bytes are always. Is that a reasonable explanation? Okay. Okay. Let me show you a few refinement modulo descrambling examples. So remember, the top level property that we claim is that the C-like Galena implementation refines modulo scrambling the swap server specification. Here are some simpler implementations that also refine, or in a couple of cases do not refine, the specification. So, for example, here is one that kind of trivially refines it because it has exactly the same structure. So this is a kind of slavishly accurate implementation of the specification that just does exactly what the specification does. And it refines the specification modulo scrambling. Here is another one that refines the specification modulo scrambling in a rather trivial way. All this server does is it accepts connections. It accepts connections one after the other. It never communicates on the connections that it accepts. And that's fine because as far as the tester knows, any bytes that it sent to the server are just delayed in transit, and it hasn't seen the results come back yet. So as far as the tester can see, the behavior of this server is correct. Here, though, is a server that is wrong. So it accepts a connection, receives something on that connection, and sends back 0. So this is a little bit interesting because the very first exchange will look correct because 0 is the first thing that should come back from a server that's initialized with 000. But the second byte is wrong. And here is a trace, probably not the shortest trace, but a trace that shows that that the behaviors of this server do not refine modulo scrambling the top level spec.
So why will the transcripts not shrink?
That is, yeah. So why did this example not shrink? Because we are generating it in a way that that does not yet support shrinking. Since I'm almost out of time, I should probably say what that way is. So how do you generate tests for this? The way we do it is we randomly explore the interaction tree of the server, of the implementation. So we randomly generate behaviors by exploring this computation tree. And if you think about that, it makes it clear why it would be hard to shrink such things. Right, because you can't just knock something out of the middle because that was a step that you had to take in the computation tree to get to the things that came after.
Benjamin.
Yes.
I think this trace has the shortest length. You could shrink the byte unit.
Okay, thank you. So so you could make the bytes less crazy looking, but so let's look at what happens. So we accept a connection 1. And then we send it 3 bytes, and it sends back 0. And then we accept another connection and send 3 bytes. Yeah, that's right. So we can't falsify it based on just this because it's not sending any more bytes until it's received some, until it's accepted another connection and received some bytes. So this connection can't falsify the refinement, but we can open another connection, send 3 bytes, and now what comes back should be, well, something other than 0 in any case. Should be probably C. And what comes back is 0. Okay, so it does actually happen to be a minimal test, although we couldn't shrink it if it weren't. Okay. Here's a server that only does 2 connections and then stops doing anything. Here is a server that does 3 interactions and then stops. And these all refine the specification. And then here's one more that doesn't. This one is interesting because it doesn't in a slightly subtle way, which I'm going to skip over in the interest of time because I want to come back to testing. And I'm not going to belabor the point except just to say, here we have QuickCheck. Oops, compiling some stuff, and then actually testing does an actual server, the C server. Sorry, we're testing a bunch of things here. We're testing that the C-like Galena server, when randomly explored, seems to have traces that match those of the server. This is also something that we have 99% proved. So this is the content of the top level claim, but we're testing it rather than proving it. And then this thing at the bottom is actually testing main.c. So it's testing the correct behavior plus a couple of mutants that we've inserted in main.c that make it misbehave. And this testing is actually happening across the network. So we're taking the specification and some testing infrastructure and extracting it to OCaml and binding it together with a little runtime library that does socket stuff and communicating with the C program, which is listening on a socket on the other side of a network. And finding the inserted mutants. Okay, we're out of time, so that's kind of a high-level picture of what all of this looks like. I've said a couple of times 99% finished. There are a couple of little pieces left in the proof that the C-like implementation refines modulo specification, the top level thing. We believe they're true. We believe that a few days more hacking will get the proofs to go through. But for truth in advertising, it's not 100% proved yet. We believe it's pretty close. And then what you'll see on Friday is that the C to C-like Galena is, what's the current status? 100% finished or 99.98? Very close to finished, modulo some picky details. And I think that is the end of what I wanted to say. Let me finish by saying, this is my last lecture, and I'm going to be going home tonight, so except for right now afterwards, I won't see you again this week, but it's been a lot of fun working with you here. I've learned a ton. I've really enjoyed your questions and interactions and meeting you, and look forward to meeting you at future events elsewhere.